Okay, good evening. Uh, Last video, we solved the problem number 1 of doubly reinforced USD method. And tonight, we will solve another problem. Maybe this is the last one. USD problem. We have the given A prime C, this one, Fy, this one, and the weight of the concrete is 24 kilonewton per cubic meter. And the required are a ultimate moment capacity, the capacity of the section, this section. The letter B is the uniform. What uniform live load can the beam carry in addition to its own weight if the simple span is 8.0 meter? This is the load diagram. This is the section. And as we know from the previous videos, we have the strain diagram. And this section have a strain diagram of this one. And this is its stress block diagram. So we will going to solve this one. Letter A and B. Okay. Solution. We have to assume the value of A. That A here is the neutral axis. We assume the neutral axis greater than 100. Meaning, greater than this 100. Maybe somewhere here. But less than 300 millimeter. Meaning, this is the 300, meaning less than. That is our assumption. Less than. Maybe the neutral axis is passing through this hole. This is actually a blank. Okay. And we will going to assume also the Fs greater than or equal Fy, or F prime S greater than or equal Fy. This is a tension failure. We assume the section tension failure. Okay, we will compute the C. C here is this one, C1. That is the C1. C1 there is 0.85 A prime C AB. A here is this one. And B is the base of the beam. This is this one, base. Okay. FC is 21. B is 450. And the A there is unknown. Okay. So we will going to compute this, will give us 8.03250 A. This is a variable. We will going to solve this after a while. Okay, kilonewton. Then we will going to solve the C2. This is the C2. And the equation to solve the C2 there is 0.85 A minus 100 times 150 there is this one. 150. C2 there is the area of the compression area of the blank. C2 there is for the blank area. This one, C2. Then we will substitute, compute this, will give us this one, 2.6775 A minus 100. C3 here is for the compression bar. C3 A prime S Fy. We have 2 of number 15 bar. Number 15 bar have an cross-sectional area of 200 according to the specification. So computing this, Fy, computing this will give us 110.40 kilonewton. Okay, we have C3 is 110.40 kilonewton. Next is the value of T. T here is this one, T. A is Fy. We have 4,000 because number 35 bar, the cross-sectional of individual bar is 1,000. This is 4 times 1,000 is 4,000. That's why we have this one. Then value of Fy times 10 to the negative 3 to convert the unit into kilonewton. So we have this 1104.0 kilonewton. Okay, to solve the value of A, the neutral axis, we have submission of horizontal force equals 0. This one. Horizontal force, C1 minus C2. C1 minus C2. Why minus? Because this is a blank area. So we have to minus. Plus C3. This is the C3. This one equals T. This T. Okay, substituting the value of C1, this one, from the previous slide, and the minus C2, this is the C2 from the previous slide also, and plus C3. C3 is this one from the previous slide, and T is this is the value of T. When we to compute the value of A here will give us A equals 135.550 millimeter. That is the neutral axis. So our assumption is correct. A is 135, meaning greater than 100 but less than 300. So our assumption is correct. Next is to check the section for the failure condition. We assume it tension failure. So let us check. Check. C is equal to A beta sub 1. A here divided by 0.85, value of beta sub 1, because F prime C is less than 30 megapascal. So computing this, C is 159.470 millimeter. Okay, so from the previous videos, we have this equation for the Fs. 600 D minus C over C. Substituting the value of C here, this one value, and will give us 1959.0 megapascal, which is correct because this is greater than Fy. That is okay. And for the F prime S equals this equation, and D prime there is 60, this one, D prime 60, and C here is this one, and computing that, substituting that, 374.30 megapascal, which is also greater than Fy. So therefore the section is tension failure, and our assumption is correct, tension failure. So if F is greater than, this is actual, for actual, F is greater than or equal Fy. But if F prime S is less than Fy, so therefore we will going to use the value of F prime S, value of Fy for the F prime S. Okay. So we have now to compute the moment capacity of the section. That is the letter A requirement. But we will going to compute first the the force C1, C2, and this is the equation from the previous slide. This is the A, value of A is 135.555, and computing this, we have 1088.40 kilonewton. And for C2, this C2, this is C1, then C2, and substituting the value of A here, the C2 is 95.10 kilonewton. Then we will go into compute the distance of this C1, C2, C3 from the T here. So C1, Z1, this, where is it? Z1, this one. This C1, and the distance is Z1. Z1 is 680 from here up to here, 680 minus A, that is the value of neutral axis. We have that value 135.550 divided by 2, and we have this 612.25. For Z2, this one, this distance of this C2, Z2, 680, this one, here up to here, 680 minus the value of A plus A minus 102. This A is this 135.550, and the value of G2 now is giving us 562.2250 millimeter. And for the Z3, this is G3 here is 680 minus 60. 680 minus 60. This is this 60, and that is 620.0 millimeter. Okay, we have now the value of C1, C2, C3, and the T. Okay, so and the as well as the value of Z1, Z2, Z3. So we will going to compute the moment capacity. For the moment capacity, summation of moment about T, this is the T. Summation of moment about T equals 0. We have this equation. This is the ultimate moment capacity of this section. This section equals to P times this quantity, C1, value of C1, and the Z1. C1 is this value, Z1 is this value, this one, times that, minus C2, Z2. C2 here is this 95 point. Z2 here is this one. Why minus? Because C2 here is the area of the void or the blank area. Okay, that's why we minus. Doing that, we have this 562. Oh no. Doing yes, C1 Z1 minus C2 Z2. C2 the distance, and plus C3. This is this C3. That is the compression bar. times the lever arm, this Z3. So we will go into substitute all the values that we have, C1, C2, C3, and then we will have this 613.22 02 kilonewton meter. That is the moment capacity of the section, this section. So that is the moment capacity. That is the answer of the requirement letter A. Okay, for the letter B required, the uniform live load in addition to its own weight, we have this load diagram. The length is 8.0 meter. This is the total uniform load, ultimate uniform load. This is simply supported, as we know, the moment is 1/8 WU, the uniform load times the squared of the span length. So we have the moment here 163.2202 equals WU. This is the span L, 8 squared over 8, and computing the value of ultimate uniform load, we have this 76.6530 kilonewton meter. So that is the total uniform load carried by the section. Okay, from the equation, total uniform load ultimate equals 1.4 the dead load plus 1.7 live load. So, but we know the dead load there is area times the weight of the concrete. So, the area here is 0.76. That is the this is the total deep, 760 millimeter. That is the total. So 0.76 meter times 0.45. This is 0.45. This is point meter. Okay. Minus the whole area. The whole area is the blank area. Okay, that is 200 here 0.15 and this is 0.2. So this is 1 minus 0.15 times 2, then times the 24. This is the weight of the concrete. Okay. Will give us the 7.4880 kilonewton meter. That is the dead load of the section. Okay. So we have 0.76. This is the W, this one, and we will going to compute this 76 then 1.4 7.4 plus 1.7 live load. This is the unknown live load. unknown. We have this value. We have this value. So, computing the value of the uniform live load will give us 38.92.340 kilonewton meter. That is the letter B required. This is now the additional live load to be carried by the section in addition to its own weight. So this is the answer of letter B. By the way, W dead load, service working dead load, meaning and the service live load, this is the W live load, uniform live load, this is service load, working live load. And for the ultimate dead load, you just multiply this one for the dead load 1.40 W DDL, and that is the ultimate dead load. And the ultimate live load is just multiply the service load by 1.70, and that is the ultimate live load. Okay, this is the last problem for the doubly reinforced USD method, and maybe inshallah we will going to take the next topic, which is the T-beam, inshallah. Good night. Assalamu alaikum.